We worked really well. We have a complete chain of information collection from sensors that works in many situations. We grouped it into 3 Python programs: CoAP full client, generic CoAP relay, and CoAP server. The CoAP full client program is universal. It can run on your computer by emulating values, but it can also work on your LoPy, either by emulating sensors or using the BME 280 component. From the LoPy, you can use the Wi-Fi network by setting your CoAP server address in the server variable. However, if we set LoRaWAN, the object will use LoRaWAN, which is normal. If we set Sigfox, we'll use the Sigfox network. Since we have less capacity on this network, we'll limit the capture to temperature. But you can measure other quantities of your choice. In theory, Sigfox frame sizes don't allow sending a CoAP message, but we'll be clever by using SCHC header compression. Our CoAP header contains the following elements. The type is none. The method is post. The URI is temperature, pressure, or humidity. The content format is score, and we set no response to receive only error notifications. So what will change from one message to another is the message ID and URI. We'll use 2 SCHC compression techniques. For the message ID, we'll use only 4 low-order bits, and for the URI, we'll use a table and only send the index. If we receive the following message, we can compress it to this. SCHC requires rule identifiers. We'll take 00 and put it at the beginning of the sequence. There, we've compressed CoAP to 1 byte. This leaves 11 bytes for CBOR. Now we build parallel time series for the measured values. When the array is empty, we put the measured value. When it's no longer empty, we store the delta with the previous value to reduce the size of the CBOR object. When we exceed the frame size or the expected number of objects, we send the CoAP message with compression for Sigfox and without compression for LoRaWAN and Wi-Fi. The generic CoAP relay program intervenes for data arriving from an LP1 network. When data arrives from Sigfox, we perform decompression by reconstructing a CoAP message. For LoRaWAN, we take the message and send it to the CoAP server. The CoAP server hasn't been modified from the previous time. We define a treatment for each URI that sends data to bbutter. Now it's your turn. Note that we also measure the LoPy's available memory. But for now, we don't process this value. That's a shame because it could be used to detect data leaks. It's up to you to complete the chain. For now, each resource posted to this URI returns an error notification that is sent downlink to your object. You can also modify the code in the CoAP Pi module to handle this notification. You can also, for example, look in the LoPy documentation to measure battery level. One more thing. We're close to interoperability, meaning we could make our CoAP server program independent of the measured value. But 2 parameters remain to be considered: the sampling period and the data multiplication factor. If you want, you can look for an optimal solution to send this information with the data. We'll meet to discuss it in the forum.